Hello students, this question is from GATE 2017 Computer Science morning session and the topic is going to be digital electronics. Now a question has been asked based on K-map. Now the question here is that the function is generated as K-map is f, minimum number of NOR gates required to implement f. So we have to basically write what is the minimum number of NOR gates that is required to implement this particular function f. Okay, so given a particular K-map, we can write a minimized Boolean expression. Now what is that particular minimized Boolean expression? See here, don't cares are given. Why do we use don't cares? We try to use don't care so that we can have a biggest group possible. For example, all are cross marks, then I can have a biggest group which is 16 group. If not, I will try to look for 8 group. If not, I try to look for 4 group. Otherwise, I'll go for 2 group. So here I can form a octet. I can form a quad here. I cannot form an octet here because these don't cares is not required here to form a quad, neither it is useful to form a octet. So it is I can only form a quad here. So are we going to consider this one and form a quad? Not at all, because don't cares are used only to assist the values of ones here. Because this is not useful to make a 8 group, so we are not going to use only don't cares. Don't cares can be used along with ones, but don't cares cannot be used individually. Then there is no meaning of using a don't cares. So now finally what the group that I can form is nothing but a quad group. I cannot use these ones individually. So what is the particular quad group here? The quad group is going to be f is equal to, here if you see the common term between both of them is nothing but c. Here between both of them, the common is going to be, if you see b is changing but a is going to be 0 only. 0 is represented with complement. So f is equal to c a bar. Now for this particular expression, I want to write a minimum number of NOR gates that are required. Now what are the minimum number of NOR gates required for this one? This can be written as equal to the top a plus c bar whole bar. Now a plus b whole bar is going to be single NOR gate. Because I require a complement here, second NOR gate. Okay, to implement C, its complement, we're going to use one NOR gate, and once you have C bar available, now A plus C whole bar is singly a particular NOR gate. So total, how many NOR gates are required? The number of NOR gates required is equal to 2. See, if you go by the other method, A bar C, to implement a multiplication between A and C, you require 3 NOR gates. And if you go for the complement of A, you require 1 NOR gate. So here total it is going to be 4 NOR gate. That is a wrong answer because there is a better approach available. If you see C A bar, I can write it as A plus C bar whole bar. So to represent this particular C bar, 1 NOR gate is required, and to represent this particular A plus C bar whole bar. See, basically A plus B whole bar is nothing but a NOR gate. Already I have a C bar available. So here it requires only 1 extra NOR gate. So total number of NOR gates required is equal to 2. This is wrong. Okay. So the answer for this particular question is going to be equal to